units, so it doesn't include this, which is, good. So don't worry about doing any of this for your quiz. So this is not on your quiz. What?
Yeah, we're learning this new lesson, but we're not doing this.
It's like you want to mess me up.
I don't. I really don't.
Then why are you giving us a
Because it has to do with rate of change. It has to do with stuff we've done already. So it's the same thing.
But this won't be on the quiz.
It won't be on the quiz.
What? It'll be on the next.
It's just a different method of finding rate of change. Okay. So a rate of change is a change in quantity relative to the change in another quantity. So like we said, my slope is equal to my rise over run. Or we have the little triangle thing. So this delta y, which means change in x and change in y. So whenever representing the relation using words, the rate of change will always be in units, such as kilometers per hour, steps per minute. What else can be used as a rate of change? What other rates do we use? Miles per hour? What else? Like I'm talking about stuff like miles per hour, kilometers per hour, steps per minute. What else can we use as a rate of change? Aaron?
Distance.
Yep.
Per.
Students per class. Students per class. That's fine. Well, yeah, dollars per pound, dollars per kilogram. Earnings per hour. So your salary. So when a relation is graphed, you usually get the slope, which is the steepness of the line. So remember, when my slope is a big number, it's going to be steeper. But if my slope is a fraction, it's going to be less steep. So when a relation is stated as an equation, we say it as y is equal to mx plus b. So we've learned how to find it through rise over run, the change of y over the change of x. And now we're going to figure it out using our first differences. So, is it not working again? Great. Hold on.
No.
Okay, so what the first differences is we're just looking at the changes in y and the changes in x, and we're going to figure out a ratio between both of them. So what we're doing is we're basically going from the bottom up. So my first thing is going to be 11 minus 9, which is what? What's 11 minus 9? 2. 9 minus 7? 9 minus 7? 9 minus 7? 2. 7 minus 5? And 5 minus 3.
2.
Perfect. So what do you notice about the first differences?
2.
Yeah. So when the first differences are the same, our graph is a linear graph, okay? Because it's changing constantly. Now I need to find my changes in x. So what's 2 minus 1? Okay, 1 minus 0. 1. 0 minus negative 1? Nope. 0 minus negative 1. 1. And then negative 1 minus negative 2. 1. So we know, so these are the same, and we know that my slope is my change in y divided by my change in x. So what was my changes in y? What were my differences? 2. What were my changes in x? 1. So what's 2 divided by 1? 2. So that means my slope is going to be 2. So this is just another way of finding slope. when you have a table of values, you just subtract all of the y values starting from the bottom and work your way up. And same with your x's, start from the bottom, work your way up, and then find the ratio between both of them.
Are the differences always going to be the same?
They have to be the same. If they're not the same, then you can't come up with an equation y equals mx plus b because it's not a straight line. So if your first differences are not the same, then you can like stop there and just be like, it's not a linear relation. Okay, so like I was saying, if the first differences are constant, which means the same, then my relation is linear. But if the first differences are not constant, which means not the same, then they are nonlinear, which means you have a graph that looks like this or this. So these are nonlinear because they are not aligned. So take a couple minutes to copy that down if you haven't yet. So we want to graph the relation and determine the first differences. So before we even graph our relation, we're going to use our table of values to figure out my slope. So we have our table of values here. So we have 2, 6, 8, 4, 0. We have 0, 6, 9, 3, and negative 3. So what do you notice about the x column? They're all what? Are they in order or not in order? Okay. So guys, you have to listen to this. This is important. In order to figure out your first differences, your x values have to be in order. Okay, you see how we have 2, 6, 8, 4, 0? That's not in order. And if you're going to do the first differences like this, they're all going to be different. Okay, so you have to put them in order. So what would come first? 0, and what's the y value when it's 0? Negative 3. So 0, negative 3. What would come next? No? 2 and 0. What comes after 2, 0? 4, 3. What comes after that?
Oh.
6, 6.
And then 8, 9.
Yep. There we go. So now only here can we do the first differences because everything is in order. So remember, start from the bottom, work your way up. 9 minus 6.
Oh, you start from the bottom?
Yep, start from the bottom and work up. Some teachers like to start from the first number and work down, but it gets confused. Yeah, because you have to ignore the first number and then go down. Yeah. What's 6 minus 3? 3, 3 minus 0, and 0 minus negative 3. Perfect. Good, which is good. Now I need to make sure that my changes in x are the same as well. All I'm doing is making sure they go up in the same interval as they should. So again, start from the bottom, work up. 8 minus 6, 2, 6 minus 4. Okay, keep going. And 2. So are my changes in x the same? Yeah. So now I can find my slope as m is equal to my change in y, which is the triangle, over the change in x. So what was my change in y? No, that's x. 3. My change in y was 3. And what was my change in x? 2. So my slope is 3 over 2.
And do we have to write this? Like
The therefore?
no, like at the beginning, you have to write the triangle y.
Yeah,
over-
yeah. So now I can actually go ahead and plot my points and see if I can figure out a linear equation for my line. So I'm just going to move up. Don't freak out yet. I'll come back down to this. I just want to plot my points, Sophia. So I got 2 and 0, which is right here. 6 and 6. You hate plotting?
Yes.
That's okay.
They're so annoying. Like, and for what? Why do graphs exist? Do we have to copy this down too?
The graph, you should know how to graph.
So we don't have to copy it down.
Yes.
I would say preferably copy it down.
But it's so time consuming and pointless.
How?
So we did our graph, which is good. Now, let's see if we can find an equation. So we did everything right. We changed the order, which is fine. And now let's see if you guys can come up with an equation in y is equal to mx plus b. So what did I say my m was? What was my slope? 3 over 2. So it's going to be y is equal to 3 over 2x. And how can I find my b value? The number that hits the y-axis, Aaron. Yep. So my graph hits the y-axis at -3, which means my b is going to be -3. So my whole equation is y is equal to 3 over 2x minus 3. And first differences to be checked, and they're the same.
X is 0.
Hmm?
X is 0.
What do you mean?
Because the first.
Yeah, yeah. So your y-intercept, your x is 0, so it's 0, -3. Did you not get a straight line? Oh no. Okay, 1 minute and then I'm moving.
This is like time pressure.
That's why you have the video. So that way you can
I
listen.
hate watching those videos.
Wow, that's so I put in so much
Oh my
work and
goodness.
effort and I get this.
It's because I get really distracted.
So let's move on.
You want?
Hey, what about the ABCD?
Oh,
What do you mean?
There says
sure.
graph and then first difference and then ABCD.
Oh, I think that was the answer to each of these. Yep. Whoops. Let's try that. Good thing. So is this linear or non-linear? That's A. Linear, right?
Oh, but where's the, oh, never mind.
So this is A, linear, non-linear. What's the slope? What did we say our slope was? 3/2. What is my slope, positive or negative? So is it going up? Yep, it's positive. What's my y-intercept?
Oh,
Yep.
-3.
So write 0, -3. And finally, we figured out our line is y is equal to 3/2x minus 3. Okay, so again, if we have a linear relation, your graph is going to be a line. My first differences are always going to be the same. And remember, when it comes to the equation, I have y is equal to mx plus b. As you can notice, my exponent on top of the x is what? When there's no exponent, what is it automatically?
1.
1.
Oh,
So both of these guys have a 1. If for some reason they have an exponent that's not 1, it's automatically nonlinear. So you have to make sure that there's
is it
no
plus
exponent.
T?
Plus b.
Oh.
So
The
for your
stick is too short.
mistake. Yeah, sorry. So my nonlinear relation So I don't have a line. My first differences are not the same, and the exponent on top of the y or the x is going to be bigger than 1. So examples of that would be y is equal to x squared plus y squared is equal to 25. Those are examples of a nonlinear relation,
Do you have to write this down?
preferably.
Preferably?
Some examples of this and trying to figure out if it's linear or nonlinear. So Sophia, the first one, y is equal to 3x plus 2. Is this linear or nonlinear?
What? Like
So look at,
graph?
is it? I'm just asking if it's linear or nonlinear. Pick one.
Fit.
You have a 50-50 shot here.
You see, yes.
If we look at the definition,
Why are we doing this? I'm confused. How are you supposed to say that on a graph?
look, it's linear. Thank you, Miguel.
Oh, here.
Yay, good job, Miguel.
It's linear.
Miguel's smart.
Okay.
Miguel is
Um,
No.
let's see
I
this
was
one.
right?
The next one.
Was I
Can
right?
someone tell me? You know this answer to that. Is y is equal to -5 over x? Is that linear or nonlinear?
It is nonlinear.
Okay.
'Cause you just have a
So let me take you to my good friend Desmos, and I'll show you why.
I'll graph it for you right now.
It's pretty easy. The graph.
You just guess. No.
This one is nonlinear because my exponent's negative. So that's what this graph looks like. Whoops. 5 over x. Yeah, so it's nonlinear, guys. Pay attention. It's nonlinear because this is what your graph actually looks like.
What is this? This looks like someone's heartbeat.
No, it does not. If your heartbeat looks like that, you're dead.
So yeah, so that's what that graph looks like. Okay, Kobo, next one. C. Y is equal to 5x squared minus 3. Linear or nonlinear?
Take a guess.
Kobo,
Non is not linear.
nonlinear.
You're wrong.
My exponent is 2. Look at that. Yes, Daniel.
Wait, so what are the exact positions we look at to see if it's linear or nonlinear?
So it has to do with my exponent. So if my exponent is not just a 1, then it's nonlinear. The reason why b is nonlinear is because it has a negative exponent. Because this x is at the bottom.
So D linear or no?
D is linear. Pardon?
It's -5 times x to the negative.
So this is written as y is equal to -5 times x to the -1. What did I say about changing negative exponents into a positive? Reciprocal. So what's the reciprocal of x to the -1? 1 over x. Thank you, Abhinav. That's equal to 5 times 1 over x, which is the same thing as saying negative 5 over x. So the next one,
Oh, I'll guess.
Miguel, is it linear or non-linear? Is my x at the bottom or is it like it's linear?
Good job. It's a 50-50.
Okay, the next one, y is equal to 8 to the power of x. Non-linear.
Non-linear.
Because my exponent is x. And the last one, y is equal to 35x.
No,
Linear.
because it has an X. So, wait.
No,
I'm so lost.
the reason why e is non-linear is because my x is my exponent. Okay?
Oh, so.
What's wrong with that is your graph is going to look like this.
I'm not feel like I get it. but I don't.
Is that a line? No.
So it all depends on the exposure.
Pardon?
So
Yep. I said your exponent has to be 1. Did I say your exponent can be x?
Wait, but
No.
I don't get it. Literally, though E and D look the most similar I've ever seen.
No, they do not. So
But
think
is it
about
because
it.
X, is it because X is like where the power is?
Yeah, that's exactly why.
Shut up.
Because I said my exponent has to be 1. Did I ever say my exponent can be x for it to be linear?
Oh, fair.
No.
So if the exponent is beside, like just chilling beside 35, then it's fine.
Yeah,
if it's above it,
because I'm taking 35 and multiplying it by x, and because my x has an exponent of 1, then it's linear.
but then once it's above it, then it's not linear.
Yeah.
It's bad.
There you go. Yeah, I know. I can't. Yeah, I can't do my alphabet, man.
No, that doesn't.
Okay. Let me just. I think that.